excited to have our first in-person speaker, Professor Joshua Blumenstock, who's at UC Berkeley, and he wanted to introduce himself, so I will pass it over to you, Josh.
You just finished. That was good. No, what to say, I'm an associate professor here. My appointments are in the School of Information at Goldman School of Public Policy. My background, my training was originally in computer science, and then in grad school I sort of did a pivot towards economics. So most of the papers I write are like some combination of either computer science conferences or econ journals, or sometimes they're like more general interest journals. But hopefully there's some connections here to demography, maybe less so to formal demography, but at least there is connections to migration. So this is joint work with, I was just telling Aisha that I started when I was a first-year assistant professor at the University of Washington in like 2011. And the paper was just published a few months ago. Guanghua was an incoming PhD student at the time. He's now a senior data scientist at Meta. Yeah. So the question we're going to look at is migration. And apologies that these slides are mostly tailored to like a economist audience, so you might pick up on that based on the citations and some of the way that the problems are framed. But it's an incredibly consequential decision that people make, and it's influenced by a host of factors. And this is just a few of the classic ones that economists like to focus on: wage differentials, amenity differentials, migration costs. But a lot of the papers, do they influence, or to what extent do they influence? And if you sort of step back and look broadly at social science, you see two main mechanisms that are emphasized in the literature. One being that social networks give migrants or potential migrants access to information. It could be information about jobs, it could be information about networks and or wages or local amenities, what have you. But it's sort of like one distinct line of argument. And another that's like, this is a bit of a caricature, but I would sort of argue that there's fundamentally different mechanisms at play when you're thinking about the role that networks play in allowing for social support and risk sharing. And these are very different literatures, at least in economics. And I should also note that like even within these two high-level mechanisms, there's substantial disagreement. Like generally, people tend to think that more information about a destination network would make migrants more likely to go there. But there's some interesting papers that suggest that it's like a very nonlinear relationship, that at a certain point there's actually diminishing, like a negative effect of additional information. Likewise, with risk sharing, there's these two papers here, this Munshi and Rosenzweig and Melanie Morton, they basically argue the opposite, that on the one hand, you would think social networks, they're looking at home networks, that strong social networks at home might enable individuals to take riskier strategies, like migrate. On the other hand, the Munshi and Rosenzweig paper argues that strong social networks actually disincentivize people to migrate because the fear that the people left behind would be sanctioned by the social network at home. And they find, both in India, essentially opposite results, although they're looking at slightly different types of migration. This is all to say that there's still a good deal of ambiguity about even the sign of the effect of how these different types of networks might influence migration. The paper ended up being a bit of a Frankenstein paper that has like very long appendices. I'm probably only going to cover the first half of it. But the second half of the paper is actually not as much about migration as it is about social networks. And so just in the first 5 minutes, I'll give you a little bit of a feel for what I'm not going to cover. But I think what we try and do in the paper is relate this question of how social networks influence migrants' decisions about whether or not to migrate to a broader question about how people derive some sort of value or some sort of utility from their social networks. And so I think like the dichotomy I put on the prior slide about information channels versus risk sharing and social support channels, I think also carries through if you look at like more theoretical research on social networks. Matt Jackson is like a classic guy who's doing this, Arun Chandrasekhar, both at Stanford. And so there's a handbook chapter that Matt Jackson wrote about like thinking about formally about utility and capital and networks, where he characterizes these two as, on the one hand, information capital, and then on the other hand, cooperation capital. So his definitions: information capital, the ability to acquire valuable information and or spread it to other people through social connections, versus cooperation capital is the ability to exchange favors and transact with others through network position and repeated interaction and reciprocation. And so, like, just to give you a sense of what we're talking about here, you're going to see a lot of figures that look something like this, where I'm going to represent people as nodes and the edges as relationships between people. And so the point here is that there's different types of social network structures that are better optimized for transmitting information versus like reinforcing social capital. And like when you're thinking about risk sharing and favor exchange, these sort of quilted network structures are generally what theorists, and there's plenty of empirical evidence too, seem to think best enable these sort of reciprocal exchange patterns. Because basically, like if you look at this person here, their relationship, let's do this example, sorry. Right, their relationships are basically reinforced by common neighbors. So like 4's relationship with 5 is somehow encouraged by cooperation and sanctioning from 3. Versus like a information exchange network where there you tend to see like star patterns are more optimal for transmitting information. So basically this node here can get information from this node here via only a couple hops. It doesn't really matter about the quilting patterns of those networks. And so, like again, broadly, I'm going to caricature the information, the network structures that are conducive to information as ones that are, you know, scare quotes, more expansive versus cooperation as being more interconnected or quilted. Okay. And so this is just. Let me know if I should like stop and start talking.
Sorry, we should be good now.
Okay. This is a review article basically making the same point, that it's very hard to understand the role of networks in migration because both pieces of that equation are hard to observe empirically. And so what you see in the empirical work that's looking at how networks influence migrations is people are using like proxies for networks rather than directly observing the networks themselves. So there's this very famous paper like Ivan Munshi looking at Mexican migrants in the United States. The key point of that article is that, one of the key points of the article is that like exogenously larger networks facilitate migration, but he doesn't actually observe networks. What he looks is like historical patterns of rainfall, and he knows that that sort of can tie that to migration and says, okay, well, when we observe historically large patterns of rainfall, we know that that's creating these networks between origin and destination communities, and then you see future migration is correlated with historical rainfall. And these other papers use similarly clever but very different strategies, like this Laurie Beeman paper. There was like a refugee resettlement agency that randomly assigned refugees to different states, and so then asks, are people from these, you know, emitting countries more likely to go to the states where this agency randomly resettled people? And the answer is yes. And so then Laurie concludes that this is driven by these network connections. But again, not directly observing the network connections, but sort of inferring based on homophily between like groups. Okay, so what do we do? In this paper, the key empirical lever is that we have access to data from a mobile phone company in Rwanda. So I'll talk a lot more about that in a second, but we're going to use that data to study the relationship between social networks and internal migration. Internal migration just because that's a limitation of the data set. Once people leave the country, they drop out of the data set. And so I think there are a couple contributions. The first, and actually what I'm probably going to mostly focus on today, is just to provide a more nuanced set of descriptive statistics about what the relationship between social networks and migration looks like in a way that would be very difficult if you were working with traditional survey-based census-type data. And so just to give you it doesn't really come through that well on the slide, but and I'll come back to this a little bit later, but like intuitively, what we're asking is, let's think of A, B, and C as three different people who are considering whether or not to migrate. And for now, let's imagine that they're all based in one location, like Berkeley, and they're all considering migrating to another location like Ann Arbor. Right? So we're holding a lot of these things fixed. Let's imagine it's all being done in June 2024, so that's also fixed. So in other words, and they all work in the same job, and they're all the same age and same general demographic. So a lot of the things that might otherwise influence the migration decision, we're gonna hold fixed across these three individuals. But the things that we're allowing to vary, and this is where the slides aren't really coming through, so this is the way to read this figure. These are the migrants, and then there's a dashed line here separating their home network, and you can't see it, but they each have 3 connections at home, basically like 3 friends. Oh, you can see it better here, yeah. So they all have 3 connections at home, and then they have 2 connections in Ann Arbor. And then those connections each have, well, in this figure, each of the 2 connections has 2 connections. And so what are the differences between these figures? Well, the home networks are the same for all 3 of them. The difference here and here is that the 2 connections in Ann Arbor for A are not connected, but they are connected for B. And in C, the difference between A and C is that one of the 2 connections actually has 3 friends of friends versus both only having 2 friends of friends. And so what we're going to generally do is look at how these marginal changes in social networks correlate with marginal changes in propensity to migrate. Is there a question?
Yeah, could you just say, maybe you'll get to this, but are those connections the same connection, like qualitative? Maybe you'll tell us how you measure connections, but are you holding that constant?
No, it's a really good question, and we're gonna, it's actually, I think, a key limitation of what we'll be able to say. We will look at a couple different ways of defining connection, but they're all very crude, and they're all based on phone data. But I'll talk more about this. So I think, again, the first contribution is this. Yeah, go ahead.
Follow up to the same. So you do not have overlapping alters, or you cannot identify if they are connected to the same person.
We can. Oh, yeah. So we know, for instance, if like this node is the same as this node or this node or something like that.
But you are looking at it from the ego's perspective, like you are not constructing the network as a sociocentric way, you know?
Ask if it's not clear later. Ask.
Sure. Thank you.
I'll provide a lot more detail. This is still like the big picture overview because I probably won't have time to get to everything. And one thing I definitely won't get to, which is we use what in economics people refer to as like a structural model to try and say something more about like how the systematic patterns in those differences allow us to infer something about like, in particular, this sort of thing here. So the way to think about this like simple equation is that we have an individual I, and we're going to say that that individual I migrates if the utility that they get from their destination network or their destination graph exceeds the utility from their home graph after accounting for like a bunch of other factors that are different that might provide differential utility to the migrant. And that's some like individual effect. And so again, I'm not really going to get into this, but what's sort of fun about this paper is that the key question that a lot of social network people are asking is, how do you define this? How do you define the utility that an individual gets from a graph, like an arbitrary, like one of those figures that I was showing you earlier? Like, how much does the like C or the G3 utility do you get relative to the G2, right? That's something that's very hard to like directly query, but because we observe the like revealed preference migration decisions of millions of people over several years, that gives us a bit of leverage into actually being able to parameterize this utility function. Okay. So that's sort of like the high level overview. In terms of the data, we're going to rely on this data set of call detail records. How many of you guys have ever like seen or read a paper that uses call detail records? Okay, maybe a third. So what are call detail records? Well, they look like this up here. Actually, just gesture over here. So what you get is anytime anyone makes a phone call or receives a phone call or sends or receives a text message, the phone companies, and this is true in the United States as well, generate these log files where what you see is a timestamp, the ID of the caller and the receiver, and then the cell phone towers that the call was routed through. And so here's a map of Rwanda. small country in East Africa, showing the locations of all of the cell phone towers. And so what this means is that when a person makes a call or receives a call or a text message, you know their approximate location at that particular time. And by approximate, I mean roughly you can place them within like one of these Voronoi cells. So it's not perfect, right? Like there's some load balancing that goes on. So you're not always guaranteed to be routed through the closest tower, but you know that the tower that you're routed to is relatively close to you. And so again, we're not observing any of the contents of phone calls or text messages. We're not observing continuous GPS traces or anything like that. But in Rwanda, we might observe for a given individual their location 3 to 7 times a day, okay? To the resolution of the nearest cell phone tower.
Is this all one company, Josh?
This is all one company, and we're sort of fortunate. We're looking at data between 2005 and 2010, and they were effectively a monopoly operator in Rwanda at the time. Now, I'll come back to this later. In that period of time, it was not nearly, like penetration ranged from like 15 to 60%, and it was not representative by any means, and so I can say some more about that. Okay, so you can imagine how, well, I will tell you more about how we're going to use this sort of data to measure both migration and social network structure. So for social network structure, we basically get it by ignoring everything except these 2 fields here, the 2 IDs, right? So what we'll be doing in the analysis, we'll be taking snapshots of the network for say like a given month, and we'll look at all of the contacts that people have during that month over the phone network. And for like our base specifications, we're just going to define a contact as anyone you spoke to in the month. But then we'll also look at things like defining contacts as anyone you've spoken to more than like some threshold number of times, like 5, to get at like strong ties versus weak ties and that sort of thing. But so just to give you a sense of what it looks like, this is like one egocentric network. So we look at one individual eye, that's the big green dot, and then we look at what this is showing you is all of their direct contacts and then their second degree network. In other words, the contacts of their contacts. And we've sort of color coded it to make it a little bit more intuitive. The blue dots are the contacts of I who live in the same district as I, okay? And then I, in this case, was actually someone who migrated. And so then we look at, in the place to where the destination that I migrated to, we look at all the contacts that I had in that destination in the month prior, and those are the red dots here. And all the non-blue, like all the gray dots are friends of friends, okay? That's not quite true. The gray dots, the big gray dots, are I's contacts that aren't at home or in the destination district. There's like 30 districts in Rwanda, so one of the other 28. And then the little white dots are the friends of friends, not the direct contacts, but the contacts of contacts. So that's how we infer network structure. Then we're going to connect that network structure to the migration decisions. And then just a little bit on like, what do I mean by migration decisions? Well, this is like the raw data animated for one particular individual. It's actually that same individual from the last slide. We picked this person, A, because they're a migrant, and B, because they have a lot of data. This person makes a lot more calls than most people. But what I'm showing you here is like the flashing white dots are the actual cell phone towers that that person uses, where each frame in this video is like a day in this 4 or 5 year panel. And then the red dot doesn't matter too much. Sorry, there's 2 red dots because of my cursor. But the like moving red dot is, we have this algorithm behind the scenes that's trying to infer essentially where that person slept that evening based on the set of all of the towers that they used. And if you were, as I was talking, this person started out in this Northwest region, and then, early mid-2008 migrated to this region just to the east of the capital, Kigali. Maybe one other thing worth pointing out, you can sort of tell here, there's basically one urban area in Rwanda. It's in and around the capital of Kigali. Most of the rest of the country is rather rural. There's a couple like smaller pseudo cities. But also you can see that the density of cell phone towers roughly corresponds to population density. Okay, so how do we actually get, and this is just another way to look at the data. This is that same individual. This might actually be a different individual, but it doesn't really matter. Each of these is a different district. So I mentioned there were 30 districts in Rwanda. Each of these is a different day. And I'm just sort of showing you like on which on any given day which districts this person made phone calls from. And so behind the scenes, we have like an algorithm, it's like a scanning algorithm that looks for contiguous sequences of calls in order to infer migration. And if you want details on that, there's a paper, but I think for the simplicity of this presentation, I'm gonna focus on what's maybe an even more like parsimonious way to define migration, which is what's on this slide. So we're gonna say a migrant is someone who spent most of our analysis has used K equals 3. So someone who spent 3 consecutive months in one district, and then the subsequent 3 consecutive months in a different district. Someone who is a resident or a non-migrant is someone who spent 6 consecutive months in the same district. And then there are a bunch of people that don't meet either definition, right? Like people that are bouncing around a lot, or the 2 months here, 3 months there, 2 months here. They wouldn't be a migrant or a resident. So we're gonna, at least for most of the stuff I'm gonna show you today, exclude that 15% of people from the analysis. And here's like 3 examples of like, this is a migrant because they were in Kigali and then they went to Huye. This is a resident because they stayed in Kigali. And this is a neither resident nor migrant because they have like a pattern that doesn't fit either mold. Okay. And just to give you a sense of what we're looking at in the data, like ignore this column. If we look at just like one single month of data, we have 50 million of those transaction records from 432,000 unique individuals, of whom 21,000 meet that definition of migration. And then we can do things like disaggregate by location, rural to urban. Here, we're using like the census definition of urban areas, which is shown in this map. Red is urban, green is rural. Of course, the way we think about migration is sensitive to that parameter K, like whether we require that they're in one location for 3 months and another location for 3 months, or one location for 1 month and another location for 1 month. And this table, if you can see it, is sort of just showing you how things like the implied migration rates depend on the number of months that you're using to define a migration event. Again, for most of our analysis, we're going to pick this value 3, partly because like the closest thing there is to real migration data in Rwanda was the survey that was done in 2009, where they used, one of the questions they asked in the survey was whether or not a member of the household had migrated in the 3 months prior. And based on that, they have this like 12% estimate, which is not so far off from our 14% estimate that we get from the mobile phone data. We also do a bunch of like data validation in the paper where we compare. So this is that CS band survey. They put out a report and they have a figure like this in there. They frustratingly didn't have like the raw data. So Guanghua took like a ruler and held it up and like wrote down the migration rates, the blue lines here, so that we could reconstruct it ourselves. And then we calculated the migration rates ourselves from the phone data, and those are the red lines. So there are some similarities. There's also some differences. It's not perfect, but again, the phone using population is not representative of the normal population, so it's not that surprising that we see these differences between the census data and our data. Also, it's fundamentally different, like what we're observing and what the census is asking about. Let me just articulate a few limitations that I perceive, and then maybe pause for questions. I've already talked about this issue about non-representativity. I have data on this if you actually want to see what it looks like, but as you might expect, circa 2008 Rwanda, phone users are more likely to be men, they're more wealthy, they're better educated, they tend to be from like the 20 to 35 demographic, disproportionately relative to young and old. Also important to mention that a phone number, I'm going to be calling them people, but what I'm really talking about is phone numbers. We observe unique phone numbers throughout the data set. We don't know if like someone handed the phone to their partner and the partner traveled or something like that. And we're going to just have to make some simplifying assumptions. Also, this sort of gets to Aisha's question that the phone network that I'm observing, and I will just in shorthand refer to it as people's like contacts or friends. Obviously, that's a subset or it maybe not even a subset, it's a different set than their actual social contacts, right? Like we might observe like incidental communications, like business transactions and so forth, and misinterpret those as social contacts. But more likely, there's probably a lot of social contacts that we're not observing that are just people that people communicate with, especially locally, that they don't communicate with over the phone network. Now, at this period of time, there was really no email or WhatsApp or landlines. So I think most long distance communication we observe in the network, but of course people might have long distance contacts that they don't actually communicate with even over a 4 or 5 year period. And so look, I think all of these are important concerns. I'm gonna generally argue that I think these do dramatically limit the external validity of this paper. So it might be more appropriate to call this paper like Migration and the Value of Social Networks amongst Mobile Phone Owners in Rwanda circa 2008. But I think the main thing I hope I can convince you is that like, what I think are the key like substantive results about like how networks influence the decision to migrate, like the causal identification that we're going to use shouldn't really be too influenced by these issues, but you should feel free to disagree later. Okay, let me pause for questions.
I'm just like, do you have a sense of what people, these I guess were relatively early adopters, like what were they using the phone? Same things introducing phones. Was it more for business, or was it mostly social, or both?
I would say it was mostly social, but a little of both. Like there, at least at this time, there wasn't like yellow pages for mobile phones, but that doesn't mean people weren't using phones to make business connections. But I think it's somewhat, well, no, I'll just leave it.
And like mobile money isn't here.
Mobile money was here, at least in a very early form. It wasn't mobile money, it was mobile transfers. So it was airtime transfers. So you could transfer airtime to someone and then they could cash it out, sort of. It was pretty common, but this time it was like maybe like 15% of the user base was using it. Yeah, I have another paper that looks at how those airtime transfer patterns were influenced by like shocks and natural disasters. I could talk either off about it. Yeah.
Are the networks evolving in discrete time?
Discrete to the second,
Okay.
so basically continuous. Yeah.
And do you have any idea of how the structure of the networks that you're looking at are similar or different to other observed human networks in terms of like credit closure, density, diameter, things like that?
In this paper, no. Right? Like we don't have any. I think I forgot to say this. Like we observe no sociodemographic information about people or the relationships between them. All we observe is this phone data set. It's anonymized, or it's like pseudonymized, so we don't observe names or self-declared gender or location or anything like that. There are other studies that have looked at like the extent to which data revealed in these like digital trace network data sets matches underlying networks. And I think the short answer is it totally depends on the context and the data set. Like Twitter data and Facebook, well, Twitter data in particular is not very reflective of underlying social networks. In general, mobile phone data, especially in low income settings where people aren't using email and WhatsApp and other forms of digital communication, tends to be much more representative amongst the people that use that like technology. But the bigger problem is that like in rural areas where people don't have phones, you know, it's totally different. Yeah.
So you use the term home and destination, but in the data, you're not able to sort of differentiate whether the destination was actually the person's home before you start observing.
Yeah.
So are you able to somewhat, I guess, empirically determine patterns of like, do people respond differently, or the number of connections could be different from where they're originating from?
Yeah, that's a really good question. So so absolutely, yes, we could observe that in the data, at least within this like 5-year period. We don't know anything before, we don't know anything after. For the most part, when I say home, what I mean is always going to be relative to a particular point in time, T. And I'm going to say a person's home location at T is defined if they've been in that location for 3 consecutive months, and undefined if they haven't been. And for most of the analysis, we're going to restrict to people whose home is defined in a particular window T. But we can also, and I might have it on that summary statistics slide, do the sort of thing that you're suggesting. Oh yes, sort of this last column here, like circular migrants. We can ask what percent of people, this is showing you here, like left that location for another location and eventually returned. Again, without really taking a stance on whether the first or the second location was home. We just know that there's like an ABA pattern in the data. And so some of the analysis we'll do later will look specifically at these sort of like return, repeat migrations.
I know your reason for using K30, but did you do any tests of other length of time, maybe 4 months, 6 months, or whatnot?
Yeah.
See if the data results, if it differ at all.
We did a little bit. We mostly did like 2 and 4, partly because once you get to 6, you start to lose people. Like there just aren't a lot of people that are persistent in the data, like in every month, continuously meeting those patterns of migration, migrant and non-migrant. And likewise, in shorter months, you tend to get a lot of noise. So, I mean, I've done quite a bit of work with phone data looking at migration, and I think the right way to think about it is like not the best tool to replicate a census-defined measure of migration, but like a nice perspective on internal mobility and movement, like taken on its own terms. Like it quite literally is telling us how often people are like engaged in patterns of like sequential location, like, oh, where did it go? Well, like that one where you like, 3 months and then 3 months, or 3 months and then 9 months. You can toy with that. But if you're trying to get back to some like very specific census definition of migration, I think the like phone data is not really going to let you do that, because of all people in the world, I've probably worked with some of the most and longest phone panels, and the longest data set I've ever worked with is about 10 or 11 year panel. And that's like unheard of in this sort of space. Most people are working with 3 to 4 year at most panels.
I have a question about the phone number duration. So what happens if someone switch phones and keep their numbers? Can the company track that?
Yeah. So just to be very clear, in that little figure I showed you where we had the 2 IDs and the 2 locations and the time stamp, we actually observed more than that. So in the raw data, we observed for every transaction for each individual a phone number, a device ID, and a SIM card. Right? These are 3 different things, each of which is unique. Right? And so we sort of made a decision based on like our understanding of life on the ground in Rwanda that the phone number was probably the best because it is portable. Like you can lose your device and plop in a new SIM card, but get back your old phone number. And so there was a lot of that, but it's still very possible that someone loses their phone number, it gets deactivated. I think if you don't use it for 9 months or something, it gets deactivated, and then someone else can turn it on and it becomes their phone number. So that, in our analysis, that would sort of get washed out in the data cleaning process because we're having that 9-month gap would mean that we would never be connecting them before and after, but it certainly is an issue. I guess one I had sort of skipped over this. We do other things with data cleaning to like remove businesses, like we take out the top, I can't even remember, 2.5 percentile of nodes based on their total degree and total traffic. So we filter out, for instance, individuals who have more than like 400 contacts or who make more than, I can't remember, like 2,000 calls in a given year. We think that those numbers and all of the like direct traffic involving those numbers before we do this analysis to try and remove like businesses from this.
I was
In the back first.
Oh, thank you. My sense is that in those developed countries, migrations oftentimes occur from rural areas to urban areas. But those rural residents, oftentimes they don't have cell phones and are excluded from your data. Does that mean that the migration estimates are significantly under?
Yeah, so I think that's a good point. Like, certainly in this era, 2005 to 2009, I would strongly caution against using the raw phone data to derive like national statistics, unless you're doing something very careful to correct for selection and non-representativity. And so I'm going to try and, in the paper, we try and steer away from like making any claims about whether those numbers of migration rates or anything are like, we would never tell that to the Rwandan government if this is like what migration. Now, more and more you see like Rwanda has like 95% phone penetration amongst adults now. So now, 2024, it's not crazy to imagine doing that, but there's still a lot of like landmines because even if people have phones, they're not using them as much. And yeah, there's a whole, I don't know, cottage industry around like thinking about developing traditional statistics from non-traditional data. This paper is not in that bucket. Do you have a question?
Yeah, I was wondering about two things. One was geographical proximity because you have the cell towers, and if that can give us an indication of two things. One, if people are co-located, like close to each other, and they make contact with each other or not. The second thing is if it allows to profile people in terms of saying this is a like close to university area, or this is a close to a downtown area, and this could be students, or this could be like, because it's business hours, this could be people who are working there, something like that, to get at that issue with socio-demographic information.
Yeah, we don't do any of that in this paper, but there are many, like order of 50 to 100 papers that are doing that sort of thing. I don't think the geographic precision is high enough to like determine which are members of a household, but certainly members of a like university campus or something like that. And if you're interested, I can point to a set of papers that do this. Yeah. Let's save that for the end.
Okay.
That's gonna take a long time. The short answer is this data set, there was a UC Berkeley professor who was like advising the president of Rwanda on telecommunication infrastructure. And so through that relationship, got access to the data, but it's a whole can of worms. Okay. Am I supposed to go till 2:30?
We can lead into some of the
Yeah.
break time. I think that's okay.
Nonetheless, I need to
We
let-
have a 15-minute break, which
yeah.
welcome to dentists. Maybe we'll hold up all of
Yeah,
them.
Yeah, let's hold questions for a minute. All right, I've already sort of talked through this diagram here. Like this is the question. I'm going to skip a lot, but I think this is important. The intuition behind our entire, because we are going to actually not try and do more than just say these network structures are correlated with migration decisions. We actually want to say something causal about to what extent do specific types of networks make more migrants more likely to migrate. And so that's going to require a lot more machinery behind causal identification. But intuitively, what we're after is what I was talking about earlier, is like how marginal changes in network structure relate to subsequent decisions to migrate or not. But just to give you a feel for what happens, like before we worry about causal anything, if we just look at like the correlation between the number of contacts a person has in a destination, like the way to read this figure is amongst the people, so take all people in the data set, you know, about 1.5 million people in a given month, but we have, I don't know, 96 months or something that we're going to analyze. So we have whatever 96 times 1.5 million people is observations. We say amongst all the people that had exactly 10 contacts in a given destination at time t, migrate to that destination at time t+1. And that is about 4%. Right? So right away, we have some interesting patterns here. We see that no surprise, well, maybe some surprise, that as the number of contacts you have in a destination increases, the migration rate increases. But what's pretty interesting is it's sort of linear, this relationship. And this like our right away rejects a couple papers hypotheses that suggest that there should be this like at least diminishing returns or potentially negative effects at some point. So basically going from 10 contacts to 20 contacts increases the probability of migration from 4% to 7.5%. But of course, there's a lot going on here. and I hope you, like, when you look at this figure, you should be skeptical, because you could say, oh, well, it's probably the case that the people who have 10 contacts in the destination, let me give you a few things that could be wrong with this. Like, maybe they like developed those contacts in the destination in T and T-1 and T-2 because they already knew they were going to migrate in T+1. So it's actually reverse causality here. It's not the network causing migration, it's the migration decision causing the network formation, which then we observe later as migration. That's one whole set of like simultaneity, endogeneity concerns. There's also all sorts of omitted variable bias, like maybe people only have 20 contacts in urban areas. And so because migration rates are higher to urban areas, we think that, it's not surprising that you see that this whole set of people over here is comprised of the people going to the urban areas in Kigali. So we have probably like 15 pages of the paper and 20 pages of appendices devoted to like trying to tease. I mean, these are very important concerns. If we're gonna say this is a causal argument, not a correlation, but I sort of talked through all my time already. But a couple things that we do just to give you an intuition. One thing is we'll look at lagged migration decisions. So we'll say, okay, what is the probability of migrating S months in the future given network structure at time T minus S? Because yes, it's true that people might still strategically be planning their migration decision and forming contacts in advance, but it's a little bit less binding the farther that gap is. The other big thing, this is, well, maybe this is interesting too. This sort of falls in the set of not quite results, but still interesting to see. We'll look at like how the structure of networks evolves over time. So this is taking a sample of migrants who migrated at time T. And what I'm showing you is the percent of contacts they have in their home district and in their destination district and then in other districts. And what we would be really worried about is if, for this endogeneity concern, is if like a few months before migration, they started talking more to people in the destination, right? But what we see is that, first of all, up until maybe like 3 months before migration, not much is changing. But if anything's changing, it tends to be like the opposite of what we at least were worried about, that people tend to talk more to the people in the place they're leaving rather than in the place they're going to. And this is sort of a placebo test. If we look at the structure of non-migrants, we see, as we would expect, no changes. Let me skip that. The other big piece of our identification is we're going to use sort of like a death by fixed effect strategy here, which is to really control for all sorts of stuff that you would never be able to do with a normal data set, because we have literally hundreds of millions of migration decisions if you count that as a month person destination. So we can say, like, as I was trying to do intuitively with those figures earlier, let's imagine that A, B, and C are all in Berkeley considering a migration to Ann Arbor. We can do that, and in the month of June 2024, like a origin destination time fixed effect will sort of hold all of that constant across people. There will be other things we can't hold constant, like a person's job. We don't know that. But the other big thing we'll do, oh, I thought I had it here, is most of the analysis is actually going to hold fixed a person's immediate network, right? And only look at changes in their higher order network, right? So the idea is, does Dennis's likelihood of leaving Berkeley for Ann Arbor, let's, given that Dennis has like 10 contacts in Ann Arbor for the entire period he's considering the migration decision, well, the changes in the connections of his network 3 months ago, how does that systematically correlate with Dennis's migration decision? And the argument we're appealing to there is that while Dennis might be able to like form and break ties 3 months in advance, knowing that he's going to Ann Arbor, it's a little bit less easy for him to like induce his friends in Ann Arbor to change their social networks in anticipation of his arrival. Okay, so that's, sorry, the hand-waving version of this identification estimation. So let me like show you the results. I'm going to focus on like 3 different margins. One is just what I'll call degree, which is the exact number of contacts. That was that linear figure you saw earlier. And then the more interesting ones go all the way back to the first slide, or I'm gonna contrast some notion of support, which is like the interconnectedness of a network, and this concept of like, what did I say, expansiveness, like the friends of friends, okay? So just before moving on, this is that same figure before, but now controlling for all of those fixed effects that I mentioned. And right off the bat, we see that like the actual values have changed a little bit. The slope is a little bit flatter, but the same general linear pattern exists, that basically elasticity 1 of migration with response to network size. We also see that migration is generally increasing in the amount of interconnections of a network. And I've sort of gone over this a little bit too quickly to have you literally understand what's going on in this figure, like what's being plotted here. But the takeaway, all the coefficients are positive, meaning that for any network size, like a person who has 10 friends in Ann Arbor versus 20 friends in Ann Arbor, the effect of more interconnections between those friends is always positive. But the value of interconnections matter more the larger your network is, because those coefficients are higher. And then the one perhaps most interesting and most surprising result we find has to do with the friends of friends. So this is showing you like just the raw correlation. If you just look at the number of friends on the x-axis and the migration rate, again, we see this like positive, monotonic trend. But what's missing here is that like friends of friends is a direct function of friends, right? The more friends you have, the more friends of friends you have. And we already know that the more friends you have, the more likely you are to migrate. So what we need to do is control for the number of friends and then look at the friends of friends effect. And that's what we see here. And so the way to read this is that for people that have between 0 and 4 friends in Ann Arbor, having the more friends they have, the more likely you are to migrate. But once you get past that, having more friends of friends actually makes you less likely to go to Ann Arbor. And we were like really, really surprised by this. So we started doing a lot of digging around. And I think the easiest way to show you this is like forget all of the fixed effects and everything I said, and let's just look at the raw data. So what we did here is we pulled out all of the people who had exactly 10 friends in the destination. And then I'm showing you the histogram of the number of friends for migrants and non-migrants. And what you see is that the migrants, again, sort of counterintuitively, have fewer friends of friends. Like all the migrants that have 10 friends, this is their distribution of friends, and all the non-migrants that have 10 friends, that's their distribution. So even just in the raw data, you see that the people with 10 friends, the migrants with 10 friends have fewer friends of friends than the non-migrants with 10 friends. Okay, let me just like start to summarize. I'll just highlight these so we can come back to them if you're interested. This sort of goes back to a question you had. We do a lot of heterogeneity analysis. Everything I've talked about so far is like the average effect of networks on migration. But we look at, and in particular, we dig into this like friends of friend effect, because that's the one thing that was really like caught us off guard. And we see that for certain types of migrations, having more friends of friends actually does positively correlate with migration decisions. Those types of migrations are repeat migrations, along the lines of what we were talking about earlier, short distance migrations, and long-term migrations. So migrations where people go for a longer than 3-month stay, that actually seems to be more influenced by positively influenced by having more friends of friends. And because it's a question that a lot of people ask, there doesn't seem to be any different patterns for rural versus urban migrants, and even depending on which way you go. So maybe with the last minute, I think like maybe the most interesting question that we try to get at in this paper is why? Like, why is it the case that having like more friends of friends in Ann Arbor makes you less likely to go to Ann Arbor? Because like, go back to all of these strength of weak tie, all of these papers essentially argue the opposite. Like the more friends of friends you have, the more resources and information you have, and the more utility you should get from a place like Ann Arbor. We sort of argue that there's 2 reasons. One is that migrants may just not know enough about the destination to know how many friends of friends they have. So that might suggest that there wouldn't actually be any effect, not positive or negative. And that's consistent with some of the heterogeneity results I showed you before. That like it was long distance moves where people, like short distance moves, friends of friends mattered, long distance moves it didn't. And with short distance moves, it's more likely that you know about your friends' networks and the destination. Long distance moves, not so much. And of course, there's a bunch of like qualitative evidence that suggests where people go into villages and do network surveys, people aren't very informed about how many friends of friends their friends have. And then the other thing we do is, I won't go into the results. We think that another reason is this concept of like rivalry, that like Dennis might not want his friends in Ann Arbor to have lots of friends because he wants their undivided attention when he gets to Ann Arbor. And I think what we do in the paper is like some strong tie, weak tie analysis that came back to Anisha's question. And it's very consistent in the data that like, what Dennis wants is his strong ties in Ann Arbor to have lots of weak ties. Like, because, you know, if information rivalry is going on, it's ex post rationalization, but the idea is he's not going to lose those friends, but any of their friends are sort of captive to him as well. But what he doesn't want, and this, you can sort of see this here, is like Dennis to have a weak tie to someone in Arbor who has a lot of strong ties, right? Where weak is fewer than 4 calls a month and strong is 4 or more calls a month. Anyhow, these are much more speculative and hand-wavy results. I will not talk about any of this. And instead, I will not talk about the structural stuff. I was never planning to, I just didn't take the slides out. I will just summarize. So in the end, we're trying to say something in this paper about what drives the decision to migrate. And of course, like we're abstracting away from probably what are the most important factors that drive decisions to migrate, like wages and living standards and amenities and costs and so forth. But holding those as fixed as we can, we're trying to say to what extent the networks and how the networks influence that migration decision. I think there's like one takeaway here. What we find is that having really interconnected networks is really important to migrants. Like you want your contacts to be connected to each other. By contrast, having very like diffuse and expansive networks does not seem to have a generally positive influence on people's likelihood of migration. Okay, let me wrap there. Here's my email and a couple minutes for questions if you have.
Yes, thank you. This is really interesting. I was wondering, one way that I thought migrants could influence migrants' decision to immigrate is that their home network contacts also have connection to their destination network contact, and I think you could test for that, right?
Totally. Yeah, we actually do. There's a lot in the paper where we look at home networks, and also like non-home destination networks. Like, does it matter if you're connected to the destination via a friend at home or via a friend in New York, not Ann Arbor, not Berkeley? I just didn't talk about it at all. The home, partly because the home network results are more intuitive. Basically, like the more contacts at home you have of any sort, and the more connected they are in any way, the less likely you are to leave your home. And having home connections to destination still makes you less likely to go, but more likely than having home destinations that aren't connected, home connections that aren't connected to the destination. Like Dennis is more likely to go to, like, I won't get into that. Yeah.
I have a question about the 15% that you didn't include in the analysis. Is it possible that they might be seasonal workers or some other like migration pattern that isn't being captured?
It's possible, yeah. We, to be honest, really didn't look at that 15%. Sorry, we had our hands full with the other stuff. Yeah, seasonal migration in Rwanda is tricky because it's very short seasons and they're very irregular, and there's like 2 harvest seasons every year. I actually gave Aisha the choice between presenting 2 papers. The other paper is looking at seasonal migrants opium harvest in Afghanistan. And we're using phone data there. And to be fair, we just said choose whichever paper you want, because I had slides on this one, I chose this one. But in that paper, we do very specifically focus on seasonal migrants, and we do, and part of why we don't do it here is because I think to really do it, you have to be careful. And so like what we do in that paper is we look at satellite-based crop yield information so that we can infer for every given district in every given year the start of the opium harvest, because it changes between districts and over years. And then we use that to say, okay, we know that the opium harvest takes about 3 weeks. So we look at people whose migration pattern fits that specific timing for that specific district. And then I feel like we're in a good position to talk about it. Here, we could do a really crude approximation, but it wouldn't be that great. And to do it really carefully is like a whole nother paper.
Do one last one.
I have a question about endogeneity in the migration decisions within the social network. Were you able to incorporate any of the information about alters that have migrated to specific destinations, like as part of like a migration cascade or a cumulative causation process in your analysis?
Totally, yeah. We look at what we call these like the recent migrants. So these are people, we define them in various ways. But like intuitively what we're looking for is people that I knew, individual I knew in the home that went to the destination D prior to I's destination, prior to I's migration. And what we see there is that they matter a lot. And they matter roughly the same as like 3 to 4 connections in the destination who are just like normal connections. And that, you know, while I'm at it, that's also what we do with the strong and weak tie analysis, that having strong connections to the destination matters more than having weak ties by a factor of about 2 to 3. And also while I'm at it, like this push versus pull, we look at like how influential having destination ties is. So destination ties make you more likely to go, home ties make you less likely to go. And so the sort of marginal rate of substitution is about like 7. So for every 7 home ties, we'll roughly counterbalance 1 destination tie. That makes sense. So I know that's the last question. I was just going to leave up here this website I put up here. At Berkeley, I teach a grad class called Big Data and Development. And on, I think I got the URL right. If not, email me and I can get it to you. There's like a syllabus that has literally hundreds of papers that are in the same vein, like how can non-traditional data sources be used to study processes of development, poverty, inequality. And there's a week on migration, so there's maybe 30 odd papers about big data and migration in low-income countries if you're interested.